very good morning to all. Today we are going to see about the measures of dispersion. Myself Dr. A. Mydeen from SFO College, Department of Mathematics, Sivagasi. Measures of central tendency give an idea of the concentration of the observation about the central part of the distributions. However, these measures are inadequate to give a complete idea of the distribution. We cannot form a complete idea about the distribution from the averages, but averages must be supported and supplemented by some other measures. One such is measure of dispersion. We get into the session. Dispersion of a distribution is the amount of scatteredness of the individual values from a measure of central tendency. Objectives of the measures of dispersion: to determine the reliability of an average, to compare the variability of two or more series, for facilitating the use of other statistical measures, basis of statistical quality control. These are the objectives of the measures of dispersion. Today we are going to check in this video. The methods of measuring dispersions are range, interquartile range and quartile deviation, mean deviation, standard deviation and coefficient of variations. Today we are going to check the formulas and what is the use of these methods of measuring dispersions in this video. First one is range. It is the simplest measure of dispersion. It is defined as the difference between the largest and smallest values in the series. It is very simple to calculate. The range R, the largest value is L and the smallest value is S. We are going to calculate the coefficient of range as L minus S by L plus S. Then the next we are going to check about the range merits and demerits. So first one is merit, simple to understand, easy to calculate, widely used in statistical quality control. And the demerits are also available in this range, that is, can't be calculated in open-ended distributions, not based on all the observations affected by sampling fluctuations, affected by extreme values. Next we are going to check about the interquartile range and the quartile deviations. First one is interquartile range. It is the difference between the upper quartile and the lower quartile in the series. It covers dispersions of middle 50% of the items of the series. Symbolically, interquartile range is Q3 minus Q1. Quartile deviation is the half of the interquartile range. It is also called semi-interquartile range. Symbolically, quartile deviation is calculated with Q3 minus Q1 by 2, coefficient of quartile deviation. It is the relative measure of quartile deviation. Coefficient of quartile deviation is calculated with Q3 minus Q1 by Q3 plus Q1. The next we are going to check about mean deviation. It is also called the average deviation of measures of dispersion. It is defined as the arithmetic average of the deviation of the various items of a series computed from measures of central tendency like mean or median. Mean deviation from median, mean deviation from mean. We can calculate from mean and median. So first formula is for mean deviation from median and the second formula is for mean deviation from mean. Coefficient of mean deviation also calculated and also the coefficient of mean deviation from the mean also calculated. These are all the formulas using to calculate mean deviation in the measures of dispersion. The next one is merits and demerits of the mean deviation. First we are going to check about the merits of mean deviation. Simple to understand, easy to compute, less affected by extreme items, useful in fields like economics, commerce, etc. Comparison should be formation of different series can be easily made as derivations and taken from a central values. These are all the merits we are using for the uses of mean deviation. We are having demerits too for this mean deviation. Ignoring the plus or minus signs are not appropriate. It does not give the exact values because of we are ignoring the plus or minus signs. Not accurate for mode, but it is difficult to calculate if value of mean or median comes in fractions. Not capable of further algebraic treatments and not used in statistical conclusions also. These are all the demerits of mean deviation. Next we are going to check about the standard deviation. It is most important widely used measure of dispersion and the first used by the Carl Pearson in 1983, also called root mean square deviations. It is having one more name, that is root mean square deviation. It is difficult as the square root of the arithmetic mean of the squares of the deviation of the values taken from the mean. It is denoted by sigma. Always we are mentioning with the symbol, that is sigma. I am giving the formula for the calculation of standard deviation. It is the coefficient of standard deviation. We can calculate from this. The coefficient of the standard deviation formula is sigma by the average x bar. Next we are going to calculate the variance. It is the another measure of dispersion. It is the square of the standard deviation, and it is the formula for the variance is standard deviation squared, that is sigma squared. Next we are going to calculate coefficient of variation. It was developed by Carl Pearson. It is an important relative measure of dispersion. It is used in comparing the variability, homogeneity, stability, uniformity and consistency of two or more series. It is also used for most of the measures of dispersion. Higher this coefficient of variation is lesser than the consistency. If it is the smaller the coefficient of variation, it is more consistent. The formula for the coefficient of variation is sigma by x bar, which is into 100. Thank you. I hope you all enjoyed the session. Thank you so much.